the most abundant element in our universe, clean hydrogen holds the potential to meet global future energy needs. At Parker, we've been pioneering its application for over 50 years. From our work harnessing hydrogen on NASA's Apollo moon missions, to enabling engineering breakthroughs that lead to a better tomorrow. From production to storage, distribution to end use, we're here to support our partners across their entire hydrogen ecosystem. Locally or globally, from prototyping to scaling, ensuring safety, purity and quality. Bringing our engineering vision, unparalleled product range and understanding of compliance to help our partners navigate their own energy transition. We're clear on the importance of hydrogen in our energy future and the role we play in shaping that. It's fair to say, when it comes to hydrogen, we're in our element.
Good day, everyone. My name is Pernilla Nimmermark, and I work as a Marcom leader for the Nordic countries at Parker, and I will be your host for today. I would like to wish you all welcome to our live stream on the topic of hydrogen, the versatile gas that has been dubbed as the fuel of the future. From powering vehicles and homes to providing a clean source of energy for industrial processes, hydrogen has the potential to revolutionize the way we live and work. Today, we will explore the latest advancements in hydrogen technology and discuss the opportunities and challenges associated with its adoption. So sit back, relax, and get ready to discover the exciting world of hydrogen. Before we start, I have some practical things. This event will be recorded, also the breakout sessions. Everything will be made available to you after the event. During the whole event, you will be on mute. Questions can be placed in the window below the agenda, and if you have any comments or something that you wish to share with the rest of the audience, please use the chat. Soon I will introduce the first speaker, but prior to that I will browse you through today's agenda. Firstly, Tomas Karlsson will give us information, an introduction to Parker's technologies for a sustainable future. Tomas is followed by yet another Tomas, which is Tomas Norrena and his colleague Erkki Härö from Sweco, talking about green hydrogen production and power-to-X possibilities. They are followed by Marko Niskanen from QPower, speaking about synthetic methane enabling hydrogen-based transportation. And then we will have 5 breakout sessions on different topics, followed by a short break. After the break, Mox Murugan from Nordion Energi will answer the question of whether hydrogen is overhyped or if we should pipe down. And then it's time for Henry Boddington to enter the stage and moderate a panel discussion about material science and safety. Finally, there will be a short summary and conclusion before we close the day. Our first presenter has 25 years of experience in the industry. He is responsible for Parker's business development in the Nordic countries with a focus on secular trends. I would like to present Tomas Karlsson, Sales Development Manager. Tomas, I welcome you to speak.
Thank you, Pernilla, for the nice introduction. So, hello, everybody. I am happy to be the one that actually gets to kick off this event that we call Let's Talk Hydrogen. So, I will scratch the surface a little bit on Parker technologies for a sustainable future, and then smoothly lead you into today's subject about hydrogen. So, looking at the first picture, it's a crossroad in a forest. So I would like all of you to just think about, for some seconds, what this symbolizes for you. It could actually symbolize a lot of things linked to today's event. If you look at the mankind, It could symbolize the choice we have to take the global warming in a serious way or not. Looking at hydrogen, the topic of today, it could also symbolize all the different options that we see within the hydrogen market. And it's quite clear that one choice is probably not better than the other, but we actually need to do a lot of different things. And one crossroad can actually lead to another crossroad moving on. So this is like a society effort to get all of this working and to take the energy challenge seriously moving forward as well. For me personally, this picture symbolizes change. So avoiding, going from the status quo and some changes happening, there is always a challenge linked to that. And as being, a Parker employee, I hope that that is also an engineering challenge. Because then we as a company can actually have the opportunity to contribute in some way. To show you a little bit how, I would like to show you two different slides from our Nordic strategy that was actually created 5 years ago. So building from Parker purpose statement, enabling engineering breakthroughs that lead to a better tomorrow, we're trying to protect a legacy that has lived on for over a century with Parker engineering partner to our customers. We start by looking at the world challenges linked to today's subject, global warming, and actually the increasing request for energy. If there is any certainty, it's the fact that we need more energy tomorrow than we actually do today. And that will create more emissions. Going further to our customers, what does this really mean for our customers and their solutions? They will also face different challenges, like cleaner energy, energy efficiency, working with different alternative fuels, and also electrification of the industry and machines. And we as a company also need to understand what that means for our team and our organization. How do we need to organize ourselves in the way that we can actually meet our customers' requirements and add value in the process? So we have tried to anticipate what these changes actually mean for our customers, and in doing that we have created a one-pager that we call the route to zero carbon footprint. Within each of these segments that I will go through, there are different crossroads and different engineering challenges faced together with our customers to make an impact. Starting with the power generation and our way to emission-free energy. We are following our customers within the energy storage and distribution with concepts like battery technologies, storing energy in thermal processes, and also storing energy with alternative fuels or synthetic fuels. And the idea is to work towards optimized storage. Last but not least, the energy consumption part. So we need to work from many different ends. A part of that is making machines more efficient by using smart components, but also working from the end that we actually try to decarbonize the existing industry as well. So you will hear a little bit later on today about carbon capture as one concept. Moving forward, I would like to close the loop with our purpose statement, and also the fact that Parker are engineering products and systems within the motion and control technologies, and by understanding the voice of the customer, all our 8 technologies are actually contributing to engineering solutions within the areas of power generation, electrification, alternative fuels, and so on. Looking at today's subject about hydrogen, Parker has a vast experience of working with hydrogen, for instance, within the space program together with NASA, where, for instance, hydrogen can be used to be converted into electricity with a fuel cell system. If you look at the energy evolution over time, in a historical perspective, we quickly understand what exciting times we're actually living in today. So let's take that journey together then. Let's go 1.5 million years back. Man invented fire. We started to burn biomass. And what we have learned with history is also the fact that when we start to create different kinds of energy and also use it and focus it in different ways, it also leads to new technology advancements. Like with fire, we learned to bake bread in ovens. We also learned how to forge metals into different kinds of equipments and tools. Moving forward, we got to find that both water power and wind power actually could replace could replace some kind of manpower. Moving on further, we found out the fossil fuels, starting with coal, that eventually led to the steam engine. And at a later stage also found oil that led us to, in example, the internal combustion engine. In the 50s, in the aftermath of the World War II, we got nuclear energy. Still debated today if it should be used or not, but it could be a good intermediate solution towards a more cleaner and efficient energy future. That leaves us up to today. So at the doorstep, perhaps, of the fourth energy revolution. And with today's subject, we think that hydrogen actually have a big space in that revolution as well. Looking at my personal experience of hydrogen up until approximately 3 years ago, my personal experience is, in addition to the occasional bath or shower, actually the fact also from school where we did some chemistry lessons. So most of us has at some point produced hydrogen as well. Perhaps in a test tube together with a chemical reaction, and you got to set it on fire to create perhaps not an explosion, but at least a squeaky sound. The more advanced students perhaps got to use water and baking soda, and together with electricity, managed to create oxygen and hydrogen in an electrolysis process. Let's stay in school and look at some more facts about hydrogen. So, it's the lightest and most abundant element in the universe. According to scientists, about 75% of all existing mass is actually made up of hydrogen. It's essential for life and practically in all living things. And also 75% of our own sun in our solar system is made up of hydrogen. The hydrogen in the sun is used in a fusion process, creating solar energy for our planet. So going back to Earth, the abundance of hydrogen on Earth is mostly locked up in different molecules, such as water, hydrocarbons, and also other organic materials. So basically, we have the experience on how to produce hydrogen. It's easy, accessible, there is an abundance of it, and we have a lot of it here on Earth. So basically, what is the problem? And why haven't we already transformed into hydrogen as a key component in our energy strategy? Now, even if I'm quite experienced salesperson, I actually don't have all the answers. But as being a modern person, I've actually asked the AI. So is hydrogen the solution? And this is the answer I got, and the first sentence is quite summing it up quite well, I think. So hydrogen has the potential to be an important part of the solution to our energy challenges, but it's unlikely to be the sole solution. And why is that? We have some macro challenges linked to this. First is the cost and efficiency of production that needs to improve quite a lot. Secondly, we need sustainable energy to produce. It doesn't make sense if you use like dirty energy to produce clean energy, so it needs to be sustainable. We need to upscale the production capacity. So basically, the need for hydrogen in the future is massively bigger than the need we have today. And that also creates a kind of macro challenge. And finally, the infrastructure of the hydrogen economy. This is also a challenge. I will give you just one small example. There are many examples of that, but what's the sense in buying, let's say, a hydrogen car if there is no refueling stations? And what is the sense of building refueling stations if there is no hydrogen cars? For the event today, we have invited colleagues and customers in the business, as well as our own Parker colleagues in the breakout sessions later on, representing our different technologies. And they will talk about different topics like green hydrogen production, where we produce hydrogen from any kind of renewable source. Power to X concept, decarbonization processes. We will hear about the importance of hydrogen sealing, about the importance of controlling the temperature in a process called thermal management, and also the purity of gases and fluids with different filtration solutions. And last but not least, the safety aspect of it. Now, you may or may not have learned something or gotten new insights in this introduction, but I hope you as me is a little bit more excited about the afternoon now. So I will leave it at this and just say, lean forward, sharpen your senses, and let's go on talking about hydrogen then. Thank you.
Thank you, Tomas. And during your presentation, a guest joined me here at the table. It's Mikael Hagberg, sales leader for industrial, marine and energy at Parker in the Nordic sales company. Welcome.
Thank you, Pernilla.
Yeah. So, yeah, I think we have high expectations for the day. Mikael and Tomas, what do you expect will be the main takeaways? Will you start, Mikael?
Absolutely. First of all, looking forward to an interesting event. I think we have a great mix of speakers, topics and breakouts. Really looking forward to that. Then on the key takeaways, of course, learn more about the world of hydrogen. And then more specifically, what products and solutions that are available now and what development we can expect for the future.
Thank you. And Tomas?
Yeah, I would lean back towards these crossroads that I talked about earlier. And also the fact that, we will have many different options and paths to follow. And it's important that we work together as a society to actually make those changes. So for today, I hope actually that I can get some more puzzles, pieces to the puzzles to see the more complete picture after today.
Yeah. Let's see what we get today.
Yeah.
Thank both of you.
Thank you.
And now our next guests. They are representing Sweco. Tomas Norrena is a seasoned expert in the field of carbon capture and power to X technologies. And with his vast knowledge, he has dedicated himself to staying ahead of the curve by keeping up with the latest developments in the industry. Erkki Herre is an accomplished expert in the field of electrolysis processes for hydrogen production and power distribution concepts. He has spent years developing his expertise in this field and is widely regarded as one of the leading authorities on the subject. Tomas and Erkki, please share your thoughts.
Good day also from our side, and thank you, Pernilla, for the great introduction. Our presentation is built so that my colleague from Helsinki, Erkki Herre, will give you insights concerning the production of green hydrogen, and I will then dive into the carbon capture and power to X concepts. So please, Erkki, go ahead. The stage is yours.
Thank you very much, Pernilla and Tomas, for the introduction. Hopefully my voice will carry on. I have been a little bit sick this week, but it's my pleasure to be here discussing today about hydrogen and power to X issues. So let's get into the big picture about hydrogen and power to X. So why are we discussing about hydrogen? Why is it so important? A little bit like Tomas said earlier, to get rid of the fossil fuels, we need a lot more renewable electrical energy, mainly wind power and solar power. And we need both of these much more than we would need fossil fuels, because we don't know when wind is blowing, and we know when the sun is shining, but it's not all the day. So that's why we need more. But the problem is that there are also situations when we have excess amount of electrical energy, and the hydrogen is an important part of this circle to make everything work, to balance the renewable energy production. Hydrogen then can be also used to produce fossil synthetic fuels, used for metal refining, used, for example, in the transportation directly, but it can also be backtracked into the electrical grid with the fuel cells. There are also other things to consider in this big circle, for example, the excess heat from the hydrogen production and so on. It should also be remembered that the X in the power to X is, the X doesn't mean hydrogen, but it means all the possibilities here. And these are sometimes mixed, and that should be clear in this picture. Yeah, thank you. Now for this presentation, I'm going to discuss about few different things that are asked from me and our company when doing engineering and consultancy in different stages for the hydrogen production plants. And one of the first questions comes that what electrolyzer technology should I choose for my project? And there is no clear answer. There are some main criteria that are really important for hydrogen production plants. Efficiency, so the hydrogen production based on the electrical consumption of the plant. That is extremely important. That is quite directly related to electrical demand, so the operating costs. And also price of the investment, so is important for the selection of the technology. But there are also other criteria. For example, the production needs. This is not based only on the electrolyzer technology, but much more on the equipment supplier. Suppliers have quite different module sizes, because usually these kind of facilities are modular. There are different sizes from really small modules, but for the bigger plants, we might talk about 5 megawatts, 10 megawatts, and so on. But it is important to find a suitable for your needs. Also, the location of the plant is something to consider. Is it maybe on-grid, off-grid, near wind or solar parks? Is it near a large industrial area, or is it near the cities? This is also important topic to consider. And also the space for the plant. In some places you have much more space to use than the others, and it is quite well known that PEM requires quite a lot less space than the alkaline plants, and that is also something to consider. So before this is taken into account and most likely discussed with different equipment suppliers, different technologies from both sides, you can make the decision what electrolyzer technology you should choose. But I still wouldn't go for make the decision based on technology, but more on the supplier and what is the best in this particular case for this project. Then the next question that comes usually is that how do we make this our project profitable? What is needed? And of course, the hydrogen production is the main thing in these plants. But like stated earlier, the capital costs are still quite high, and there are some difficulties usually to make it profitable. So the secondary streams are also especially extremely important for these projects. Oxygen is get from the hydrogen plant quite easily. So when you make a plant for the hydrogen production, oxygen is quite easy to recover also at the same time. The costs don't increase too much. Of course, if you need purification, that is something, but it's still quite minor in the total costs. That's one thing. Oxygen can be used by different kind of industries. The oxygen is also extremely pure from these kind of plants, so it can be utilized and sold also as a side stream. The other thing that is maybe sometimes neglected, but especially in the Nordic countries, we have quite extensive district heating system in many cities. For example, in Finland, almost every city has a district heating system, and from the hydrogen production plants, we get lots of excess heat. It's about 20 to 35% of the electrical power, so it can be really huge. It's just important that the hydrogen production plant would be near the city to be able to utilize the heat for the district heating network. It is also required. We have to use heat pumps to utilize this in the district heating network, because usually the cooling water in the hydrogen plants is somewhere between 40 to 60 degrees, but the district heating network temperature goes between 90 and 110 degrees. So heat pumps are required, but this is really important also for the profitability of the plant. And I also would like to mention that many of these hydrogen plants are designed to be utilized when the electricity is cheap, which is really good for the profitability point of view, because the electricity price is the biggest operating cost for the plant. But when the electricity price is high, usually the heat is also needed by the energy company. So I think it would be a win-win situation if even with the high electricity prices, the hydrogen production could continue and the energy company could get the heat to the district heating network. So it would be a win-win situation, but this requires partnerships, and this is something I would like to point out, which is sometimes missing, I think, from the equation. Then for the last part, what is important and what is asked from me, like a third part in my presentation, is what kind of expertise is needed and what should be taken into account. What kind of knowledge do we need for the design? Let it be detailed design, or let it be concept studies, or whatever the project phase may be. So permitting and land use planning is one crucial step. The land use planning for cities, for example, regarding the district heating aspects, and from our point of view, the plant should be closer to the cities than maybe the traditional industry has been. So land use planning is extremely important. Permitting is another thing. The rules for permitting changes a little bit from country to country and also inside countries. There should be strict rules and they should be clear for everybody, and also the speed of the permitting should improve a little bit for us to make this transition faster. Knowledge and experts regarding safety are much more needed regarding, for example, ATEX issues, explosion simulation and structural design, how to design safe plants from structural point of view also. Electrification is one topic. Electrical quality is important thing, especially nowadays when we get lots more wind power to the grid. But now, if we get hundreds of megawatts of hydrogen production and therefore lots of rectifiers to the network, the harmonic filtering becomes much more important, because the harmonics reduce the quality of electricity. So these should be taken into account when designing these kind of hydrogen plants. HVAC is also important. It's a little bit related to the ADEX issues, because if we get some leaks of hydrogen, we need to have a good and working HVAC system to reduce to minimize the possibilities of any excess hydrogen gathering in the places where it shouldn't be. I would like to end my part of the presentation by the summary that new skill sets and expertise are needed rapidly to make this transformation much more fluid for everybody. Thank you, and let's go to Tomas.
Thank you, Erkki, for the great insights regarding the green hydrogen production. I will start my part of the presentation by saying a few words of my current career. So I'm working as a development manager for Sweco, and I've been with the company for 5 years now. Sweden is our biggest Sweco country, so I'm happy to join the event live here at Malmö. Personally, I'm responsible for circular economy related business development at Sweco Finland, and I'm today representing our industry and energy division together with Erkki. At the consulting business, you have the privilege to see how the industry and society will develop during the upcoming years, and perhaps in today's event, I'm able to share some insights concerning this. My background is from the gas industry, and prior to my time at Sweco, I've also been working among bioenergy solutions. So let's get the wheels rolling also from my side and head to the next slide. As I mentioned, I'm developing the circular economy business at Sweco, and I wanted to include one slide which presents how this is all linked together. On the left hand, we have 4 themes of circular economy, which are well represented in the following CCU and Power-to-X concepting. One of them being a resource efficiency, basically doing the most with what we got. Then we have renewability, recycling, and symbiosis. After all, it's about utilization of renewables, recycling the carbon, and forming symbiosis between different actors. So when keeping these aspects in mind, Power-to-X concepting acts as a great practical example of industrial scale circular economy which can transform the society. On the top left corner of this slide, we have the production of green hydrogen by using green electricity, which is, for instance, produced by offshore wind power. This part was well covered by Erkki, but I wanted to highlight how important it is to find uses for excess oxygen and heat as well. This can be crucial also for the business case. Then, on the second row, you will see the path how carbon is recycled in practice. Usually, carbon dioxide can be captured from a source such as waste-to-energy plant, and depending on the flue gas composition, there are different solutions available. Also, in this part, it is important to notify the possibilities for the heat integration. After this stage, the captured CO2 can be used as a feedstock in a synthesis process plant. Possible products are methane, methanol, and other hydrocarbons which are seen beneficial for the plant concept. In today's presentation, I will share insights concerning the production of green methane and methanol, which are looking especially interesting in the Finnish market. However, we do also have projects which are focusing on the production of green ammonia. And if we quickly evaluate the possible ways to use these chemicals, there's a wide range of possibilities, especially among industry and the transport sector. Then up to the next one, I will say a few words about the carbon capture and utilization. Carbon capture enables emission reductions as well as circulation of carbon. Depending on the utilization or storage route, carbon can be set to short or long-term circulation. For instance, the production of different polymers can enable also longer-term binding of the carbon. For post-combustion capture, there are mature and well-recognized technologies available in the market. Amine-based technologies are widely recognized, especially for industrial-scale capture. Also, hot potassium carbonate-based solutions seem interesting in the market area. However, direct air capture applications are more energy-intensive and tend to still be more in the piloting phase. These will require more years to develop. It is predicted that the economic value of CO2 could rise which supports the feasibility of capturing activities. In greater scheme of things, carbon dioxide capture opens up new business opportunities for various industries. Then a few words about green methane. I wanted to include some market insights here. The production and utilization of synthetic methane supports the green transformation, as fossil natural gas can be replaced with SNG. Usually, synthetic methane is produced by biological or chemical process routes, both having their own advantages. For instance, biological routes tend to be more tolerant towards impurities, which can be in the carbon dioxide flow. Also, the processes are run in different pressure levels, which is good to be noted when designing the overall plant concept and choosing the electrolyzer technology. Perhaps Marko will later share some insights concerning their in-house methanation technology. For the synthetic methane, there is already an existing logistics chain in place, and it can be either stored in gaseous or liquid form. From the storage point of view, liquefied methane is a bit more challenging one, as the temperature demand is rather low. It is expected that there is a growing demand for SNG in road and maritime transport. In the road traffic, the synthetic methane will be consumed in greater volumes by truck as liquefied SNG. There are also possibilities to use SNG in heavy industry, which would enable further carbon capture and carbon recycling. Last but not least, I will say a few words about the green methanol. So methanol is widely produced by the chemical industry. It can be utilized in various applications or used as a feedstock when refining other chemicals. The production of methanol by utilizing green hydrogen and captured CO2 enables more sustainable production route than the previous routes, which utilized non-renewable sources such as LNG. Methanol has a straightforward logistic and value chain, and it can be stored in liquid form at the production site. In addition to the industrial use, green methanol has a significant potential to be used, for instance, as a fuel for cargo vessels. Methanol has great properties to be utilized as an energy carrier. To conclude, green methanol can enable significant emission reductions in the maritime transport sector, in which emission reductions are more challenging to achieve. That's all from Sweco side for now, and I will also join the panel debate later today, which gives you us a great opportunity to continue the discussion. Thanks a lot.
Thank you both for a great presentation. I'm happy that you wanted to share your thoughts. I have a couple of questions. Erkki, what are the greatest challenges when ramping up the hydrogen economy?
Thank you, Pernilla. It's a good question, and I would say that there is no one single answer. I think there are a few things. The profitability is still sketchy sometimes, I would say. The number of experts are missing. That's also like stated in my presentation. That's one thing. Chicken and egg problem, like Tomas at the earlier stage said, and also the quite long delivery times of the equipment is problematic regarding, for example, some EU grants and so on. So the time schedule becomes quite tight. So here are the few, but I think all of these are things that can be solved.
Good, thank you. Do you foresee other electrolyzer technologies in the market than PEM and alkaline-based ones?
Yes, also in our project we have seen some discussion or had discussions with solid oxide electrolyzer technology. It's really promising, especially in certain locations and depending on the process a little bit, but it's still not that out yet, but it's coming really fast.
Good, thank you. And yeah, thank you for joining, even though you weren't able to travel today, and your voice worked perfectly. Thank you.
Thank you.
Over to Tomas. I have something for you as well, of course. What kind of synergies do you see for biogas and synthetic methane production?
Actually, Pernilla, that is a great question. Synthetic methane and biomethane can share the same infrastructure when it comes to logistics and value chain. So there are a lot of synergies and the investments are already in place. So basically, when we have been ramping up the biomethane industry, there's also been good work done for the hydrogen.
Yeah.
And possibilities for the synthetic methane as well.
Yeah. And before I let you go for now, how do you see the market development in Finland? What kind of industries are especially active in the power-to-X sector?
Yeah, I would say that the carbon capture utilization and the power-to-X concepting, it opens up new business opportunities for various industries, but especially the energy companies and waste management companies are now showing the way, at least in the Finnish market. And let's see how it goes in the future.
Yeah, good. Tomas Norrena, Erkki Härö, thank you so much for joining us. Our next guest, Marko Niskanen from QPower, is a highly experienced expert in power-to-X technologies with a deep understanding of how to integrate them to create fully functional plants. His expertise in this area allows him to develop cutting-edge solutions that are very effective. Marko's ability to develop innovative solutions and push the boundaries of what is possible has earned him a reputation as a true thought leader in the field of power-to-X technologies. Marko, please take the lead.
Thank you, Pernilla, for a great introduction. And like mentioned, I'm the CTO in QPower, representing QPower here today. Thank you for inviting us here. There is a lot of professionalism around here today, so it has been a good event so far. I will be talking about the role of the synthetic methane in hydrogen economy. Synthetic methane as an enabler for hydrogen-based transportation. I have 3 topics: why, what, and how. Let's start with why. Why we are here. And of course, why we are here, it's our shared target in fighting the climate change. Here we can see the numbers, which are unfortunately familiar to all of us, but there are solutions. What we can do right now, that's the what. We should focus on solutions which are available now. That's the. I will be explaining more in the later slides what I mean with that, and then with how I will go through few examples that which show you that we are not exaggerating when I say that QPower technology is the most efficient for the market in some of these areas. And like mentioned, the challenge, we must reduce emissions rather quickly in all sectors of economy. And some of these sectors are harder to decarbonize with, let's say, pure electrification or pure hydrogen utilization. And the key question addresses how to do this in those sectors efficiently. Heavy road transportation, sea transportation, and heavy industry, to name a few. And this is where QPower solutions comes in. So let's take a look of a bit of our story and then to the solutions. There are many alternatives for e-fuel sector. Methane, what QPower currently does, ammonia, methanol, and many others. Some of these are more ready to implement than others, but like mentioned, we in QPower think that all of the solutions which are currently available should be implemented, that there is too much discussion that what should we do in 2030 when we should be thinking that what can we do now. And methane, we see it is the, let's say, the most mature infrastructure and end utilization wise. We have this existing infrastructure, and if we compare it to, let's say, for ammonia and methanol, the large scale infra and end usage is not there yet, but hopefully will be. And like I mentioned, the methane is already here in large scale, unfortunately as fossil-based fuel mostly. But that can be replaced with synthetic methane and of course biomethane also. Just to give you some numbers, LNG consumption worldwide was about 7% of the total marine fuel consumed. And we in QPower have set an internal target, which I will tell you more, of 500 megawatt annual production of methanation capacity. Well, between 2025 2030 or so, and this would answer to 2% part of this consumption. So the utilization end is already here and the infrastructure, and now we just need to scale up the production and implement these technologies. And let's take a quick look of how the solution works. I'll try not to go into too much of technicalities. Those can be asked in the follow-up questions later. But basically the recipe for synthetic methane is quite simple. We have carbon dioxide and then we have hydrogen. Our process is extremely robust and tolerant to different impurities. So we can utilize, for example, biogas and landfill gas, industrial CO2 and these sources as such. So the purification needs are quite insignificant. The scalability I mentioned, I will show you more about the scalability in the later slides, but the basic idea is that the plant consists of these modules, bioreactor modules, which can be then scaled up in numbers as required. We have designed these reactor modules in such a way that the scalability is easy. We can do small plants, but also larger plant. Actually, the smallest plant we did was a unit for Dubai World Expo. We delivered a very small methanation unit to Wärtsilä, and they utilized that in the expo demonstration to produce renewable synthetic methane to fire up a coffee machine. and that was, of course, just a demonstration, but still a good demonstration of the very small end scale. But of course, currently we have projects on the table for the size of tens of megawatt modules. And in the future, I hope that the number will go up. And here in this picture, you can also see the same as with before, that the concept of how the plant is being built with the reactor modules. The current reactor module structure enables the plant to require very little maintenance during its life cycle. So the operation cost remains low. And of course, the units are designed in such a way that they require little energy to keep the process running. We don't have to utilize mixing, high temperatures or high pressures. So that's why our process efficiency is the market lead. Here is also the full concept which has been talked about in picture. Tomas also presented this, but here it is fitted in the QPower solution form. We have the inputs, which are CO2, renewable electricity and water. And then we have outputs, of course, which the main output is renewable methane. And of course, in this plant concept, green hydrogen also. Some of the hydrogen can be utilized for methanation, but in many cases, some of the hydrogen can be utilized as such. And then we have this, I'd rather avoid talking about waste heat or waste oxygen. We like to talk about byproducts or secondary products, because these plants produce quite a lot of heat as a byproduct, as mentioned. And business case-wise, it's extremely important to find economical utilization for these secondary products. And of course, for the environment also, that if we input amount of energy and output some amount in product X and product Y, then both of those end products should be utilized to minimize the energy losses. And here is also a real-life case example. Same concept as with before, but not just a PowerPoint. this is the Power-to-X Solutions Harjavalta plant, which is currently being built. It's the first green hydrogen production plant in industrial scale in Finland, and QPower is delivering the methanation part for this plant. And the CO2 which is going to be utilized is industrial flue gas, and also biogas can be utilized here. And the end use for the products is industrial and traffic sectors. And the impact, I talked about our internal 500 megawatt target. As I'm approaching the end of the presentation, I want to show this goal in more depth. As I said in the beginning, we aspire to keep the carbon in the closed loop. And by end of the decade, our goal is to sell synthetic methanation production capacity 500 megawatts annually. In broad, large-scale rough numbers, this means 400 million liters of diesel, less fossil diesel utilized in heavy transportation, or equal amount of fossil energy reduction in other industries. And in carbon dioxide tons, this means 850,000 million tons less of CO2 emissions to atmosphere. So the impact is significant. And the best thing is that we are already taking in orders. So this is not just for the future, even though everybody are looking for the future and try to make the better future, but we can do solutions also today. And here is the ideal world. I will end my presentation to the ideal concept where ships would sail with wind as they used to do before the invention of engines. This is basically an ideal example of a closed loop for carbon utilization. In the ideal world, the best scenario is that we can create a closed carbon loops. And in this case, as energy does not disappear, it just changes its form. Neither does carbon disappear, and it can't be reused. So we could create systems where we can reuse and utilize same carbon dioxide endlessly, and we don't have to take new carbon into this circulation in form of fossil fuels and burning those. And if you have any more questions or you want to have follow-up discussions, I would gladly advise you to contact our dedicated customer service. Sami Lakio is the head of our sales, and he will gladly have further discussions if those needs arise. Thank you.
Thank you so much, Marko, and welcome to the table here.
Thank you.
So what do you think is the best way to battle climate change?
Like mentioned in our slides, I think that the best way to battle climate change is to apply these solutions now, which can be applied, and then of course develop further, but to take into use all the possible solutions which can be utilized. We don't see that if someone makes methanol, that's a good thing. We don't see that we should compete with it's a good thing that all of these technologies and solutions are applied, because like presented with the numbers, the market is huge and there is room for all of these and need for all of these solutions.
Yeah, so yeah, there is not one single solution, and your message is that all the solutions are already here.
Yeah.
So there is no use to sit and wait and waste time for better time to come.
That's correct. Yeah. Exactly.
Good. Marko, Niskanen, thank you so much for your presentation. And Marko will join us in the panel discussion later today. It's time to meet our next speaker, Mox Murugan. He is an experienced professional who has dedicated his career to investments in renewable and sustainable growth with a focus on natural resources in northern Sweden. With his expertise in environmental issues, he has made a significant impact on communities worldwide, especially in the development and promotion of green hydrogen as a key player in the renewable energy industry. I would like to welcome Mox Murugan from Nordion Energi. Welcome, Mox.
Thank you very much, Pernilla, and good afternoon to everyone in Europe. Very kind words, Pernilla. I'm not sure I even recognize myself. I wish you'd got that guy, but unfortunately you've got me instead. As said, Mox Murugan, Business Development Director at Nordion Energi. And I'm here today, and my thanks to Parker for this opportunity. I'm here today to talk about hydrogen, and as the title suggests, it's hydrogen, is it overhyped, or should we just pipe down? And ladies and gentlemen, I know we're still in April, but I'm going to tell you right now that there is the early front runner for Dad Joke of the Year. Because what my title is talking about is really that while there is a lot of potential in hydrogen, and it is perhaps overhyped, we hear every day ever bigger and larger projects. But there are challenges, of course, with the adoption of the hydrogen economy. And one of the main challenges is distribution, how we're going to move these vast quantities of hydrogen. And I believe some of this has already been discussed today. In my view, the solution to all of this, well, it lies below our feet. Specifically, I'm talking about underground hydrogen pipelines and supporting infrastructure. I believe that they are crucial for us to achieve our decarbonization goals. Now, of course, some of you would say, well, you'd expect that guy to say that, wouldn't you? He works for a gas TSO. But I should point out that today, Nordion Energi is not in the hydrogen market, but we will be tomorrow. And that is why I actually joined. See, in my previous role, I was, as Pernilla described, involved in the development of hydrogen projects. But I could clearly see that without the right infrastructure in place, none of this will come to pass. So that helped me to easily jump ship, make the jump to Nordion Energi, where thankfully it was also their vision. So very briefly, just some background. Nordion Energi, who is it? Many of you may not be familiar. We're basically the gas TSO, the transmission systems operator for Sweden. And we're owned by one of the world's largest pension funds. And we have a broad mix of both commercial as well as residential customers. Increasingly, those customers are choosing green gas, that is through our biogas. But as we look to the future, we're developing an entirely new hydrogen infrastructure business, and that's where I come in. So what is the importance of hydrogen transportation? It doesn't seem like a very exciting topic, and if you relied on the media, you really would say, well, it can't be that important. I never hear about it. And it's true, most of the hydrogen discussion is focused, the column inches, they go towards the colors. You know, you hear, is it green? Is it blue? Is it turquoise? And why is turquoise so difficult to say and spell? These are the minor issues that seem to occupy so much of the media's attention. But in my opinion, there are three more important metrics that we should focus on when we talk about the evolution of the hydrogen market. And they are quantity, location, and cost. See, as we increasingly modularize and mass produce the components such as electrolyzers, then I think you can say that we have a clear pathway to reduce the raw production cost of hydrogen. But in that case, when that happens, the efficient transportation of hydrogen will become increasingly important due to its impact on the overall price and therefore overall competitiveness. In fact, according to research released last year, transportation costs will ultimately comprise as much as 66% of the total hydrogen costs. So transportation very much matters. So let's first look at the issue of quantity to explain why transportation is important. According to figures from the International Energy Association, production of hydrogen has remained relatively stable, around 90 million tons per year for the last few years. However, from here, those quantities are going to start to explode. And the EU alone has a major role in that. See, last year, in response to Russia's invasion of Ukraine, we set out the new program called Repower EU, as many of you know. And under that alone will add 20% growth to the global hydrogen production. We're striving for around 20 million tons of new hydrogen production before 2030. Now, this is a vast amount of energy in terms of, if it was electric, the amount of 20 million tons of hydrogen is equivalent to around 665 terawatt hours of electricity. That's a huge sum. It's equivalent to the amount of electricity consumed by both Germany and Sweden combined. So to prepare to move this vast quantity of energy, of hydrogen, within just the next few years, as well as plan for future growth and to accommodate that, well, then we need to devise a scalable and reliable infrastructure solution. But then again, you may start and say, well, why do you want to move the hydrogen in the first place? And that's a fair question. The reason that the hydrogen needs to be moved is it's a mix of good and bad news. The good news is that we have identified large sources of renewable energy that can supply the enormous amounts of clean energy that we're going to need to produce green hydrogen. I think that's what we're all aiming for, emissions-free green hydrogen. In fact, the Nordic region alone can meet over 100% of the REPower EU domestic hydrogen production targets, but I'll go into that more in just a minute. Now, the bad news is, though, that these sources of green hydrogen production, they're almost never in close proximity to the major centers of demand. Thus, we're going to need to move staggering quantities of hydrogen from production centers to demand centers, customers. And we need to do that as efficiently and as cheaply as possible if we are to succeed in getting everyone on board. So the maps here illustrate the location challenge. The EU's areas with the highest renewable energy potential, central Spain, let's say, as well as where I live up here in the far north of Sweden, they're also some of the most remote areas. So how are we going to solve this? Well, the map on the right gives one possible solution. This shows 5 major routes of what is known as the European Hydrogen Backbone, or the EHB. This was devised collectively by 31 European energy infrastructure operators, including Nordion. And the EHB is going to be a dedicated network of hydrogen pipelines, which is going to solve all the aspects of the transportation challenge that I mentioned. That is the idea of quantity, how we're going to move the huge quantities of hydrogen, as well as location, how we're going to connect the centers of production with the centers of demand, and also the issue of cost. So how are pipelines going to help with cost? Well, forgive me, I know this is a very well-informed and technical audience, but there's always a few in there that are like me, that are extremely uninformed. Actually, just me. Hydrogen possesses some unique challenges due to its unique properties as an element. And so I just want to briefly recap some of them. Let's consider hydrogen first as a fuel. Now, as a fuel, hydrogen is tremendously efficient. High calorific value, such that if you burnt 1 kilogram of hydrogen, well, that's going to release 3 times more energy than combusting 1 kilogram of petrol or diesel. And of course, as Parker can tell you much about, this high calorific value is well known, and it's why NASA has used hydrogen to power its rockets for decades. And of course, this high value, calorific value, is also one of the reasons why hydrogen has such strong potential in our decarbonization goals. But on the other hand, some other aspects of this element don't work in its favor. And I'm talking about here specifically hydrogen as the lightest element in the universe. Now, this means it's got a particular lack of density, so that transporting hydrogen under normal pressures and temperatures is a real pain in the butt, which is a technical term which is seldom used in these circles, but it's absolutely the case. So, for example, while that 1 kilogram of petrol has only 1/3 the energy of that 1 kilogram of hydrogen, the 1 kilogram of petrol will neatly fit inside a bottle, a 1.1 liter bottle to be exact. However, that 1 kilogram of hydrogen, again, normal pressures, normal atmospheres, well, that's going to require a bit more space. It's going to require 11 cubic meters of cargo space to be exact. So to transport it, you'd need around, not a bottle, but around 1.5 cement trucks. So economically transporting hydrogen is an enormous challenge. Let's look at how ridiculously challenging it is. And okay, this is just a little bit of frivolous fun. As we increase enormously the amounts of hydrogen that we need to transport, the difficulties just become even more complex. So pictured here is one of the largest bulk cargo ships that we've ever constructed. And it has a cargo capacity, I believe, around 220,000 cubic meters, which is a lot of cargo. But in terms of hydrogen transportation, if you were to foolishly try and transport hydrogen under normal pressures and temperatures, well, that entire ship there would just transport 20 tons of hydrogen. So if you bear in mind that the Repower EU target is 20 million tons of additional hydrogen per year, and the centers of production are seldom coupled to the centers of demand, then we're going to need that ship to move back and forth around 1 million times to supply the hydrogen. Or if that doesn't seem realistic, well, perhaps we can just go out there and build another 20,000 of these ships to get the job done. Now, as I said, no one in their right mind or even in their insane mind is thinking of transporting hydrogen in bulk cargo ships or uncompressed or anything else like that. All I'm trying to illustrate here is that when you're going to move vast quantities of hydrogen, given its specific unique qualities, it is a big challenge. Now, of course, and I understand you've covered some of this already today, there are solutions out there. And the main ones that are being evaluated today are via pipelines, bias, that's the solution I'm talking about. Also as ammonia, which of course is a very hydrogen-rich compound, and also bias because I'm heavily involved in several green ammonia projects. Or you can transport it as a liquid cryogenically, or you can embed it in another more dense carrier, liquid or organic hydrogen carriers. Unfortunately, some of these solutions create new and sometimes even more difficult challenges, and we don't have time to discuss those today. But for example, ammonia, it's widely traded today. I believe it's the world's second most widely traded chemical. So that could be a solution, except if you need hydrogen on the other side, you're going to have to take an enormous amount of energy to crack it back to release pure hydrogen. Or if you want to do transport hydrogen as a liquid, that certainly is an option, but it is enormously challenging to ship around the world because, as most of the audience will know, it's much more complicated than liquefying natural gas. Hydrogen only turns into a liquid at the balmy temperature of minus 252.8 degrees Celsius, close to absolute zero, which means that if you're going to look at transnational, transcontinental transportation of hydrogen cryogenically, then you're going to have to recreate the conditions of deep space effectively, absolute zero, here on Earth, and maintain that for extended periods. Technically possible, but very challenging. So one of the issues is that technologically all of these solutions are possible, and we probably will get there, but time is not on our side. We need solutions today if we are to hit our targets very soon. And therefore, pipelines are the nearest and neatest solution because, yes, we know how to transport gas via pipelines and have done so. But importantly, and this is often glossed over, we actually are transporting gas, hydrogen gas, through pipelines today. There's around 2,000 kilometers of pipelines in existence around the world. So in terms of technology readiness level and safety, we have the track record there. So that's in the favor of moving vast quantities of hydrogen quickly. And of course, all of this is not just my view or Nordion's view. It's backed up by numerous studies, such as this one from the International Energy Association again. And it shows that for distances up to several thousand kilometers, pipelines are by far the most cost-effective solution. But cost is not the only advantage of pipelines, of course. By delivering hydrogen at the level of purity and in the gaseous state that most industrial customers are asking for, transportation is more efficient overall because you have no intermediate steps, incurring additional energy penalties or losses. And potentially also you could mention safety, that the fewer steps, there's less possibilities for things to go wrong. Furthermore, of course, the nature of pipeline transmission is such that there is an inherent storage, line packing, that it will take place as we move large quantities of hydrogen through them. Now, of course, due to the lower density of hydrogen, the line packing you get in a hydrogen pipeline is much lower than you would get in a natural gas pipeline. But over thousands of kilometers, these things still do add up, and it is nevertheless an additional benefit that will play a role in stabilizing renewable energy systems with their inherent intermittency in the future. So, having looked at why hydrogen transportation matters, I'd just like to go through quickly about what is Nordion Energy doing with all of this information. And biased view is that I think we're doing quite a bit. Over the last year, in particular, we've announced 2 major hydrogen pipeline projects that I believe have the potential to reshape the energy systems and markets, not just of the Nordic region, but all across the EU. And these projects are the Nordic Hydrogen Route, or the NHR, and the Baltic Sea Hydrogen Collector, or the BHC. Gee, these acronyms just roll off the tongue, don't they? The NHR we're developing together with Gasgrid, the gas TSO of Finland, while the BHC we're developing together with Gasgrid, as well as Copenhagen Infrastructure Partners and OX2, the Swedish wind developer. So just briefly on these projects, to give you an idea of the scale and how they can really transform markets. So the NHR is going to run across here in the upper north of Sweden and Finland initially. And the NHR's goal is to build up a cross-border market in hydrogen by 2030 that we believe is going to drive investments to support the European energy transition and increase overall access to green energy across this region. Now, the BHC, on the other hand, well, we announced that just before Christmas, and it's even larger in scale than the Nordic Hydrogen Route. That's because it covers, its catchment area is the Baltic Sea. Specifically, the area it's targeting initially is around 150,000 square kilometers. And this will allow new offshore wind power development that will first bring their electricity onshore to no less than 3 energy islands, the islands of Åland, Gotland, and Bornholm. Now, energy islands are an emerging development model where you have your offshore wind farms generating electricity, and they send their electrical energy onshore to an island where there's a centralized point for converting that electrical energy into green hydrogen. By using islands rather than floating offshore platforms, this allows a more efficient placement, operation's a big point, and servicing of all the critical equipment such as the electrolyzers and compressors. So that's why the energy island is quite an interesting concept. It opens up vast new areas offshore for development. And the BHC is going to take energy produced in the Baltic Sea and transmit that to both Sweden and Finland, but also connect to continental Europe. Possibly through Eastern Germany is where we're studying at the moment. We're still in the pre-feasibility stage, but then we will have a connection between the Nordics and Germany. Now, collectively, these large-scale infrastructure projects are going to reshape not just the Nordics, but also the wider EU market. We're talking about over 3,000 kilometers of newly built hydrogen pipeline, overall investment around 20 billion euro. At its peak, our analysis is that it will create around 58,000 jobs in the construction phase. So you can see these are going to be some of Europe's largest infrastructure projects, all connected to the transmission of hydrogen. Now, we've looked at why hydrogen transportation matters. Again, it's about quantity, location, and cost. So I'd just like to wrap up with how all of this infrastructure is truly going to make a difference. Here in Europe, I believe it's going to redraw the entire energy landscape. I mentioned earlier that the Nordics have the ability to supply all of the EU's domestic hydrogen targets just by themselves, because there's a huge renewable energy potential, both onshore in the Nordics, but also in the Baltic Sea. The Baltic Sea is a wonderful resource, and this was recognized last year around the end of August, when the leaders of many states bordering the Baltic Sea got together to sign what was called the Marienborg Declaration. Now, the declaration's goal was to end Europe's dependence on Russian energy imports and create both a greener Europe, but also an energy independent Europe. Now, under the vision, and it was a long-term vision, it hoped that one day up to 93 gigawatts of offshore wind would be developed in the Baltic Sea that would feed hydrogen production and give us this clean energy future. I'm pleased to say that as we accelerate these infrastructure plans, it's helping to accelerate the adoption of this idea, such that today, an analysis conducted by our partner Copenhagen Infrastructure Partners, we already have over 100 gigawatts of offshore wind development in the Baltic Sea today, just 1 year later. And it should be noted there's also plenty of onshore developments. So with the right hydrogen infrastructure in place, it's possible for us to achieve our climate goals on time, as well as to end our dependence on energy imports from, shall we say, less than friendly states. Hashtag no dollars for dictators. Let's see if we can make that go viral. So, final word. There is a lot of hype in the hydrogen market. I'm probably contributing to a lot of it. But at the same time, there is a tremendous amount of actual activity and investment taking place. And a key enabler of all of this is boring, invisible to the eye because they're underground, and yet utterly essential hydrogen pipelines. So thank you for your time. And if you have any questions now or later on, you can send them to me on LinkedIn. Thank you for this.
Thank you, Mox. I just realized that there is a lot of plumbing to do, or piping. Yeah, and you also mentioned that there is the investments of scale must be enormous. And how can you justify the economics of that?
Sure. I should point out, because there's a misconception that all of this, the EU is just writing checks and it's a case like they'll just build it and hopefully it will come. This is the criticism, that the hydrogen economy is built on hype. We've all heard that wonderful, they call it hopium. I disagree. You see, because most of this will be funded. Yes, there will be public support, and that is welcome and essential. But these are investments that will be made by banks, investors, entities, and new startups. There is capital that will be lined up for this. In order for the projects to go ahead, as they are now, they go through a rigorous evaluation. The business model must stand up. But for the business model to stand up, we must drive costs down wherever possible, of course. That's why I said infrastructure is important. I mentioned at the start that it could be about 66% of the price of hydrogen. So more efficiently we can transport hydrogen, the more competitive the business case will be and the more bankable the projects are. In short, all of this infrastructure is not hype, it's not public money, it is a mix of public support with a lot of private capital.
Thank you. And thank you so much for taking the time to give your presentation. I know that you are very busy, traveling a lot, and also for giving us that there is some hope for the future. Thank you, Mox.
Thank you so much, and certainly there is hope.
We are going to shift gears a bit and move on to the panel discussion. With any new technology, there are challenges that need to be addressed. One of the most critical issues is ensuring the safe handling and storage of hydrogen, a highly flammable gas. The use of hydrogen also poses unique material challenges, and it can embrittle metals and affect the properties of certain polymers. So in this panel, we have gathered experts in the field of hydrogen safety and materials to discuss these challenges and potential solutions. So I give the word to Henry Boddington, Sales Development Engineer. So please take the lead.
Thank you very much, Pernilla, and welcome to the live audience joining us here for this panel discussion. Really, really happy and delighted to be joined by the experts, as Pernilla mentioned. So we have Marko from QPower and Tomas from Sweco, and we have Gary from Parker Instrumentation Group.
Hello.
As Pernilla mentioned, my name is Henry Boddington. I'm a sales development engineer with Parker Hannifin, and I'll be hosting the panel discussion. So I want to open up this discussion now by looking specifically at kind of safety considerations relating to hydrogen throughout the value chain. And I'd like to start specifically by looking at how we might mitigate against and ensure that we're minimizing leakages through safe installation and operation. And so with that, I'd like to just pass over to you first, Marko. If you could just tell us a bit about what the key elements are to consider when containing and transporting hydrogen.
Well, you mentioned safety, and like it's been discussed, the hydrogen is quite, let's say, a difficult gas in that sense, and that it tends to permeate through materials and leak easily. So the key issue is that all the pipings and fittings are fitting for the purpose, and the basic engineering work is suitable and done with good practice, and also the installations. So it all builds up from the good design and engineering and utilization of proper materials and equipment.
And yeah, Tomas, so from your perspective at Sweco, what are your kind of recommendations when it comes to material choice for containing and transporting hydrogen?
Yeah, thanks. I would start by setting up a solid basis of design for the hydrogen project, having right engineering practices throughout the project, throughout the different engineering disciplines, and I would look it from the bigger picture. But Gary might comment from the component point of view.
Yeah, so Gary, how would you say Parker is kind of involving itself in sort of supporting systems designers and systems builders in that respect? Then,
yeah. I guess we are spending many engineering hours testing, producing, 3D CAD modeling. All the sort of normal testing procedures and outside testing as well, to make sure we've got a product that we can deliver that will give a leak-free system. And also then working with the companies for the early engagement we talked about earlier, to make sure that the system is as simple as possible and easy to maintain. Mm-hmm. So there's no point having lots and lots of plumbing just for the sake of it. We want to actually, I guess it's counterintuitive, we want to have less fittings, less connections, more manifolds, so that the system is a lot simpler.
Yeah, I would like to add that I like that approach. That yes. Simple is beautiful.
Absolutely, yes.
That's and
I think that goes for us actually.
Yeah, definitely.
So would you say then, Marko, building on from that that if we're reducing complexity, we're not actually sort of like kind of taking any away from safety considerations, we're actually making things more safe?
No, because typically when you have simpler systems, you have more less points of leak and so on. So you have less things which can fail. So we utilize that practice in QPower also, that we try to make simple but fitting systems for the purpose.
And it's easier also from the process control point of view. Mm-hmm. So yeah, definitely so.
Gary mentioned the component manufacturers point, and I would like to address that from equipment or solution provider manufacturers view, that's extremely important that the equipment or let's say a valve provider doesn't just sell the valve but has the engineering support to think for example a pipeline engineering together with the buyer of that valve. So
yes, yeah, and I think that's our heritage in oil and gas. We've moved gas, we've moved liquid, we've moved CO2 already. So this moving hydrogen is not something too difficult for us. And I think you mentioned simple. We have a process in Parker called Simple by Design, where the engineers go into something and really look at stripping it down to something really simple, making it a lot easier, less components, less weight. So we have that process inbuilt within Parker, mm-hmm. and that will go a long way for this whole process.
If we go back just a little bit, perhaps, Tomas, could you maybe just sort of talk a little bit about is there anything specifically about hydrogen that makes it a more challenging gas than other gases to transport, for instance?
Yeah, actually, that's a good question. There are some similarities if you compare the distribution and safe handling of hydrogen when you compare it to methane and propane, but the combustion range, it's a bit different. It's 7 times wider for the hydrogen. So this is something that we will need to especially take into account when designing hydrogen systems.
Mm-hmm. And then when you're talking about systems design, I mean, do you feel that there's going to be a difference within the different value chain within hydrogen? So if you're talking about electrolyzers, or if you're talking about hydrogen refueling stations or the fuel cells, will there be different kind of requirements in terms of sort of safety considerations there?
Personally, I hope that there will be similar laws for different part of the process to keep it simple. Like Gary said, less is more in this sense.
Mm-hmm. I think you've got different pressures, you've got different temperatures, you've got vibration. If it's on board a vehicle, extra things going on. But I think if the engineering is correct in the first place and the installation is correct, then there's no problems.
Yeah, and even though the hydrogen has the wide combustion range, it's easy gas in that sense that it disperses quite fast. So, it won't. You don't have pockets or anything where this hydrogen could easily go. How do you put it? Let's say that you don't have these pockets of hydrogen forming.
Yes, yeah. And not forgetting, we've been moving hydrogen for decades within industry, so it's not something that's happened today. It's just these new applications have come on board.
Mm-hmm. Yeah, and actually it was good that Gary mentioned the road transport, because we have already good practices from the transport of biomethane in gaseous form in storage containers, and rather similar containers can be used for the hydrogen as well. So let's learn from them, and let's learn from there when designing the transportation also for the hydrogen via.
So are you saying that we're already seeing sort of like a transfer of knowledge and competence and expertise across the value chain? So it's not limited to just looking at one specific function?
Yeah, definitely so. And even though the transport pressure levels are completely different, but good practices can be taken from the biomethane sector to the hydrogen sector.
Yeah, I fully agree with that. As QPower, our solution produces methane, but it does utilize hydrogen, and we've noticed that a lot of good engineering and design practices can be acquired. For example, from anaerobic digestion and biomethane production, how they do things there. So some of the principles can be applied and learned from there.
And then in terms of sort of the materials that we're looking at, so Marko, would you say that there's any particular materials that are particularly suitable for hydrogen, or any that should absolutely be avoided at all costs?
I personally, and we in QPower, think that we shouldn't at least exclude anything if there is no, let's say, an engineering practice which tells otherwise. It all depends on the temperature levels and pressures. Carbon steel can be utilized with lower pressures, like QPower's methanation reactor is low pressure, low temperature solution, so then carbon steel is fitting. But if we go then to higher pressures, liquefaction of hydrogen and so on, then the material requirements become more strict. But it all comes down to knowledge, that you have to have the knowledge of the how the material will handle the hydrogen. Will there be permeation and so on? So good information for the base of engineering is the key point.
And at Sweco, would you sort of concur with that? Or is there particular kind of materials that you're advising customers to use or not to use?
No, I definitely agree with Marko there that different materials are cost efficient in different part of the process. So I would advise to keep your eyes open for different material choices, not to be too fixed on certain material.
Yeah. And I think our customers are agnostic, aren't they, about materials? They may be looking at cost, weight, that sort of thing. So, I mean, we're looking at 350 bar, 700 bar refueling stations. So stainless steel 316, 316L is our sort of choice and recommendation. But that's not to say that is the way to go. But at those temperatures and minus 253, you've really got to be careful what to use.
Yeah, so I'd say I'm a big fan of the TV show Succession. And in Succession, they're always talking about what are they saying on the socials? What are the optics? So Gary, maybe you could just talk a little bit about what you feel, will public perception have much of a say in terms of sort of safety considerations?
I think it's going to have everything to say in safety considerations. You've got all the bodies working on safety and the publications, but it's a lot of it is preaching to the people who know already. Like some of the webinars, people know all this anyway, and they're just listening to it. A bit like some governments, I guess. What we need to do is to get to the people who don't understand it. And they may be using it, they may be coming into contact with it, either with refueling a car, or it could be in home heating, a boiler, a cooker, a gas fire. All these things are going to come in the next, hopefully, to 2030, 2040. So people need to be on board and understand it's as safe to use as any other fossil fuel.
Yeah,
There's just some little extra things maybe we need to look at, but it's no different.
Yeah, I think it's all about openness and spreading the information, because if you don't know about hydrogen, the first thing you might think is Hindenburg or something like that, and that actually didn't had much to do with the hydrogen.
Exactly.
There were other matters which caused that, but when everything is done correctly, hydrogen is as safe. So openness and early participating of communities, if these type of electrolyzers and plants are being built, the early participation and discussion with the communities is the key to success, so to speak.
Mm-hmm. And then Thomas, I mean, would you say to the audience, for anybody who's maybe a layperson for hydrogen, that there's any more kind of inherent risk with building hydrogen systems as opposed to kind of traditional fossil fuel?
I would say that every time when we are playing with fuels, there's a slight risk. But when it comes to hydrogen, it's when the engineering disciplines are working according to the well-known practices and guidances and following the standards, I don't see a specific risk regarding the hydrogen, but of course there's slight risk always when discussing and playing with fuels.
Yeah, and the risk mitigation, of course, I think that this HAZOP, like this risk analysis, they need to be done with good care and are by the book with these. That is something which should be addressed.
Yeah, there's a lot of work needs to happen in the background, whether it's engineering or process or procedure or training, at the background to deliver what we need to deliver. It's not just going to happen just like that. There's a lot of work goes on with doing all these guys and ourselves. Yeah.
I mean, one of the things that we know with building out the infrastructure for hydrogen is the sums that we're talking about for simple systems are also, quite eye-watering. But then would you say, Marko, that cost is going to have an implication here relating to safety at all? Or do you think that safety is just far too important to even kind of look away from or look at costs?
Safety is, of course, it has to be safe, so you cannot build unsafe system if you want to cut costs. But again, I will return to, let's say, good engineering, that when you build a safe system, you have correct materials for the application, fitting equipment for the application, the cost efficiency follows. So when you do things systematically, looking the whole big picture, then the cost efficiency will follow, but you cannot cut corners, so safety has to be first.
Mm-hmm.
Yeah, I definitely agree there that safety is the first matter. And we cannot lose the trust of our end clients. For instance, the persons who are driving hydrogen vehicles and stopping by the distribution stations, they need to be able to rely on the safe handling and distribution of hydrogen. So there's no room for error there.
Mm-hmm.
Yeah, and talking about errors, there was an incident recently. I don't know whether I want to cover that or not, but incident just south of Oslo with a tank that had an incident there with not grave results, but it was an incident. Now, luckily, the company involved, which is really to their credit, were open about the incident and looked at the reasons for the incident and really got down to the understanding of why it happened and have publicised that as well. And that's something that we need, that we perhaps haven't had in the past. Where if there's something to be learned, then the publication of the incident and the findings are really key.
Yeah,
and I think that was really nice and transparent. It's good.
I suppose that kind of lends itself to then sort of, ensuring that the public doesn't lose trust, and just all of a sudden, one incident can just set the whole industry back.
Absolutely, and we don't want that now. It's been quite a few decades in the making, all this, and I think we really need to make sure it happens, but happens safely.
Which I think, is a good way to transition now to the next topic that I wanted to cover, which is education within hydrogen. So there seems to be, it's been a huge shift now in terms of sort of interest and market development. And what I want to know from you, Marko, is what do you feel like the current level of education and understanding is within the marketplace?
Of course, I mostly can talk from the Finnish point of view. I think that the base education, at least in Finland, it's in good level. But as it is a new, let's say, sector of economy, the green hydrogen business, then you have to learn by the trade. So for example, when we have been hiring quite a lot of new people in, we've had very motivated and let's say, interest, who have highly motivation to work with the green hydrogen and renewables, people who have good ground education, but it always there is this ramp that you have to have this learned by the trade. But I think that if something is always good, I would see that is it an engineer or is it a salesperson, it's good to have also the view from the top from time to time that you're not just fixed in your box, that you understand the whole. So this is something I think could be improved, that the education would give a more broadened view than just that particular subject, which is the main subject.
And it's an exciting time for young people to get involved in the green technology, if you like now, whether it's in hydrogen or CNG or LNG. And we'll see more people coming forward. We're working with universities and colleges from sort of 18 plus, 17 plus, who are really getting into it and building hydrogen hubs in the UK. So I think it's a really exciting time. And if you're thinking of a career, engineering,
How about you, Thomas? I mean, do you feel, because you're working across the kind of the value stream, do you see differences in segment to segment, or do you feel that sort of the level of understanding is sort of fairly even?
I would say, and add to Marko's comment, that technical universities in Finland provide good readiness for the future specialists to work in the industry. But it's important point from Marko that we need to accept that we learn on the way. So I don't see a specific process where we would be lacking like a skill set or experience, but it's a learning path when we are going forward with the industrial scale projects. But at Sweco we've been doing cooperation or close cooperation with the universities in the Nordics and also with the research institutes. So I think that it's good to have that discussion ongoing.
Yeah, I agree. And to add on that, I mentioned that maybe the education level, these universities and so on, might add more of this system thinking, that you would see the larger view, not just inside your specific box. But I also would like to add that also companies should have responsibility in that sense, that they do good initiation and when new people come in, it's a key thing that those new persons are introduced to the business properly, because otherwise the results are not good. So I encourage other companies also to put resources on that.
I have a question for the panel, I guess. Sorry. Do you see, I think in the UK we see spin-offs of universities into then commercialising what they've been working on, whether that's fuel cell technology or battery. Is that something you see in the Nordics, that you have a university and then these guys get together and they spin off into a business?
Yeah, of course, QPower is a spin-off from a research project, not in the university, but in the National Research Centre of Finland. That started as a research project from there, and then it formed into a company, and now we are in business, so to speak. So it is something which you see. I think well, again, from the point of Finland, there are a lot of spin-offs and inventions made, but I would like to see more that they would evolve into, let's say, growing businesses. A lot of time these are acquired by larger and older companies, which is not a bad thing if there is resources, but if it leads to that something is acquired and there are no resources it to grow, then it's a bad thing.
Yes,
so.
and you can't stifle the creativity that a small company brings.
Yeah.
Then Thomas, going back to a point that you made earlier in the discussion, you talked about sort of cross-pollination from across industries.
Yeah.
Do you see that as being a big positive, or do you see that there's any downside to sort of like kind of borrowing thinking from other industries?
No, I think it's only positive thing, and we don't need to invent the wheel again in a way. And I could add to the previous comments as well that as the companies are now going forward with their first like hydrogen production plants also in Finland, I think it's key to have an open mindset and share the best knowledge and experiences as they are going forward with their projects for the other companies, which might be in a different phase, but to have this like thinking and mindset that we are doing this together. So I think that's important.
Yep. And then, Marko, do you see that there's any kind of future skills gaps that sort of need immediate addressing? You know, when we're talking about sort of the time frame that we want to kind of get things sort of up and running.
Well, what we've seen is that it's in the project we have. Let's say that pipe engineering, this which sounds very generic, but we might have a long, let's say, time periods that if let's say a project needs pipe engineering to be done, those are quite fully booked. So this basic good engineering, that is something which we might be. I mean, there are of course resources in different companies like Sweco, but it seems that this good basic engineering, piping, ladders, scaffolding, mechanical. Firms are hiring constantly everybody who they can get. So this good basic engineering, and of course then the special areas like hazardous areas and ATEX, which was mentioned. This type of thing plays a key role, that the systems are built safely and economically. That the base engineering work there is good.
Mm-hmm.
So.
And I would say that engineering and consulting companies plays a role there. We can act as a bridge between the old industrial factors which have been already playing and treating hydrogen for several years, for decades. And then when you think about the new companies coming to the business, ramping up their first production sites, I think engineering and consulting companies can share the knowledge between these two, like different type of actors in the industry. So
I feel like knowledge sharing and collaboration has been a big feature of what we've discussed so far. And Gary, I know that Parker is involved with quite a few different forums and clusters. Do you want to kind of just talk a little bit about those kind of bodies that we're involved with and how that kind of benefits Parker, but also benefits the broader community?
So I think from the very top, we're in the Hydrogen Council. That's a CEO-led organisation. So thinking about policy. And then on a more local level, we're involved with the Northwest Alliance in the UK. So that'll be a big cluster in the northwest of England. We're getting also involved in Redcar and Cleveland on the northeast side of it. There's going to be a lot of activity around the northeast and the Humber. We're involved in various universities around the country as well. So I think that sharing of minds and networking is real key to it. And I was networking events of the week with our competitors, but it was nice to be able to share things openly and discuss things openly without being too sort of closed in.
Well, I said, sort of adding to that, I mean, do you feel that, you said that you're there with our competitors, but that it's a completely closed shop, or is there going to be necessarily one kind of supplier that wins everything, or is it too big a market to be dominated by one?
I would hope it's too big a market to be dominated by one, because looking at the number of gigawatts that is talked about, whether that's in Nordics or in Europe as general, or in the UK, the supply chain needs to be ramped up in massive amounts.
I agree. Same with this.
How can we? Yes, no.
Yeah, same with the electrolyzers and also methanation. That I would happily see that there would be other, let's say, methanation businesses also, because I think it's not a healthy market in any sector if it's dominated by just one. It's good for the whole business if there are lots of players who are successful.
Yeah. And what we have seen also when you think about the project life cycle and project schedules is that there are already bottlenecks regarding the electrolyzer part because of the long lead times. Yeah. So in that sense as well, it would be good to widen the market a bit, to have more suppliers to be answering to the demand.
Yeah, and about the bottlenecks, we've seen that mentioned. Good engineering work needs to be allocated to project in the early stage, but also Tomas mentioned the electrolyzers might have a bit long lead times, but that actually is in all parts very crucial that the project has good supply chain management, because now the situation and delivery chains are such that if it's not managed and watched with very carefully in every sector, then you will have trouble.
And it can't be undervalued, supply chain. I know people go on about it all the time, but supply chain is important, and it's important when you want to get that piece of kit out the door and you've got one piece missing, whatever it may be. It won't be a Parker piece, I tell you, but there could be a piece missing, and that's tragic, isn't it? You know, you've got your client waiting for the green hydrogen revolution and you're waiting for a little widget from supplier X, and that's tragic. So with supply chain management, the right people in that as well, and keeping in touch with the company early enough, I think that's the key.
Yeah, Gary mentioned previously that there's a growing demand for engineers, but I would say that the procurement plays a significant role as well in these kind of projects where the market standings or market situation is what it is. It's very important to know that what you are procuring and what is the best fit for your project.
Yep. Well, unfortunately, we seem to be kind of running very short of time. We have a lot more questions that I could ask this panel here. We've got fantastic resources here, but I think it's time to wrap up now. So I'll just go down the line here. And so, Marko, if you'd like to just sort of say what you believe to the audience are the kind of key takeaways from this day and this panel discussion.
Yeah, well, of course, the point which I have been saying for this day is that we have solutions available now. So let's do the things which we can right now, and let's not wait for 2025 or so. And well, regarding this, I would like to point out that we have been discussing about safety, but I think it also this leak issue is also a resource efficiency thing, because if we think about green hydrogen and you have leaks, it's mainly a safety issue, but you are also losing a crucial resource. The hydrogen has been produced with green electricity, and then you have that production has gone to loss if there are leaks. So it's also an economical thing. Of course, safety first, but that is also why good practices and equipment are crucial.
Yeah, I would briefly sum it up that we would need to have an open mindset towards different solutions. Like Marko had included to his presentation, there will not be a single like power to X road, which is the leading one. There will be needed many options. So we will need to have eyes open for them. And up to Gary.
Okay. Yeah, so this new revolution needs a different way of thinking, I think. And we can do it together, and we can do it safely together. So please engage with us, and I think we're in for a good future.
Yep. So that just leaves me to say a big thank you once again to the panel.
Thank you.
Marko, Tomas and Gary. And I'll hand back over now to Pernilla.
Thank you, Henry. Yeah, thank you for a very interesting debate. Your insights and perspectives were truly valuable and provided us with a wealth of information and knowledge. It's time to conclude and take a moment to provide you with a brief summary and our key takeaways from this afternoon. So, Mikael Hagberg, please wrap up the day.
Thank you, Pernilla. I got the pleasure to wrap up this great event. We have been listening to great presentations. We have attended to breakouts and also listened to a very interesting panel discussions. And I got a lot of new insights to hydrogen. Coming back to the question this morning, the key takeaways from today. Personal reflection, there is of course a lot of challenges with safety, transportation and cost, but also a lot of possibilities because there is products and solutions available already now, and we need to start now to reach the climate goals and also to make Europe independent from import of gas, like Mox said, from less friendly countries. We as Parker have a goal to be carbon neutral 2040, which is great. But I believe the biggest impact we can do together with our customers and partners by enabling engineering breakthroughs that leads to a better tomorrow. And finally, a big thanks to all of you that have been listening. I hope you have been inspired and that you have learned something about hydrogen today. Then I would like to send an extra thanks to our guest speakers, Tomas Norrena from Sweco, Marko from QPower, and Mox from Nordion Energi. And then also to our Parker team, Gary, Henry, and Thomas, and to the leaders of the breakout team. And finally, to our fantastic host, Pernilla.
Thank you so much. Before we close, I would like to ask you a favor. Later today, you will receive an email with a survey. It will only take you a few minutes to fill in, and the information and feedback that you provide us with is very valuable for us for planning for next event. If you have something that you would like to discuss with someone at Parker, there is a link to an email address in this very email. So you can submit a question there. Finally, I hope that you have gained some new insights today. And thank you for listening. And bye for now.
Roger, in the next phase.